Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode problem number 338, counting bits. Given an integer n, return an array ands of length n plus 1 such that for each I, where I is in range of 0 to n, answers of I is the number of ones in the binary representation of I. Fine. Now, let us see this example. If n is equal to 2, they have given the input as 2. We have to return an array in which the zeroth position denotes how many set bit are in 0, and the first index denotes how many set bits in index number 1, that is in number 1, and the second index denotes how many set bits in number 2, right? So this is the question. Let me explain here. Just assume if n is equal to 10, let us take a small number 7, right? Now 0 1 2 3 4 5 6 7 are the indices. How many set bit in 0? It is 0. How many set bit in 1? It is 1. How many set bit in 2? It is 1. How many set bit in 3? It is 2. How many set bit in 4? It is 1. How many set bit in 5? It is 2. How many set bit in 6? It is also 2. How many set bit in 7? Which is 3. Because it is 0 1 1 0 0 0, and this is 1 1 1 0 0 1 0 1, and this is 1 1 1 0, and this is 1 1 1. So these are the binary representation, right? And these are the indices, and these are the elements. That is how many set bit in 0, set bit in 1, set bit in 2, etc. So this is what the output. So how to approach this problem? So I can write a function, just a function inside which if I give a number n, it will return the set bit in n. Okay, this is a function. Just assume this is a function. First of all, I will give this 0 and it returns 0. I will store here. Then I will give 1. It gives 1. I will store here. Then 2, then 3, then 4, then 5, then 6, and then 7. So I will give one by one those indices to the function, and that function will return me how many set bit in that number, in that index, right? So this is the first approach. Now how to write this function? We already seen that we have two approaches. To write this function. They are first approach is a basic approach, by which we, if take for example, it is 101, it is 5. Now whether this LSB is set bit or not, yes, it is set bit. So increase the count. Right? Now right shift it by ones. Now whether it is set bit or not. Again right shift. Whether it is set bit or not, yes. Increase the count. So the first step is we want to see whether the LSB is a set bit or not. And the second step is we want to right shift. So this is the first approach. Now second approach is, as we know, is a Brian's algorithm. What is a Brian's algorithm? I want to do an operation called n is equal to n into n minus 1. That is n and n minus 1. Until n becomes 0. N becomes 0. Fine. So in each iteration, the result will be incremented as 1, because in each iteration, using this Brian's algorithm, every set bit will set to 0. Take for example 101. What's this number? It is 5. Now 5 minus 1 4. 100. Do AND operation. What is the answer? 100, right? Again. What is this number? It is again 4, right? Now 4 minus 1 3. 0 1 1. What is output? 0 0 0. So it's output in 0, right? Now how many steps involved? This is the first step and this is the second step. So totally 2 steps are involved. So output will be 2. So this function returns 2. Right? So this is the Brian's algorithm. In every one step, in this step, this bit is set to 0. In next step, this bit set to 0. So this is what the branch algorithm teaches us, right? So we can do in this any of the two approach. And talking about the time complexity and space complexity for this approach, time complexity and space complexity, as we know, there is no auxiliary space, so the space complexity is O of 1. And what is the time complexity? Time complexity is, we are doing some stuff for totally n elements in the array. We are doing some stuff for totally n elements in the array. For each element, I have to do for log n times. Log n times, because see here are 3 digit in binary representation, and I want to do this process for 3 times. If there are 5 digits, I have to do for 5 times, right? So it is log n. Fine. Now, because since we know n is equal to n right shift 1, which can be written as n is equal to n divided by 2, right? Whenever we are reducing something by 2, the time complexity will be log n, right? So this two approach will be at the time complexity of n log n. Fine. Now can we optimize it? Let us see, because as we know, it is a continuous thing, right? It is continuous thing. Like just observe this. This is so much important approach. Just assume 1 2 3 4 5 6 7. Now let us assume how many bits are here? 0. How many set bit? 1 1 2 here 1 here. For 5 is 2 2 3. Right. Now let us take a number maybe 6. What is the binary representation? 1 1 0 1 1 0. Now how can I split the 6 so that I can compute from the previous values, Just assume we know all these values. We know all these values. By using these values, I want to find the set bits in the 6. Okay, so I can split it as, I will do a right shift 1 and I will do underwidth 1. So that here comes this 2 bits. This 2 bits comes here, right? And the single bit 0 will comes here, right? So now observe carefully. It is the binary representation of 3. It is a binary representation of 0, right? How many set bit in 3? It is 2. How many set bit in 0? It is 0. So 2 plus 0 is equal to 2. Fine. Answer. Fine. Let us take another example. If it is 7, 1 1 1. Same. What we have to do? First of all, right shift by 1. By doing right shift, it will be like 1 1. And again, take and operated with 1. It will be 1. So what is set bit of 3? Set bit of 3 is 2. And set bit of 1 is 1. Right? So 1 plus 2 plus 1 is equal to 3. Fine. Finished. So this is the DP approach. This is a DP approach. If you are following my playlist, you would learned it already. But still, for new user, I am teaching again. So this is a DP. So dynamic programming approach. In this approach, we use just for some bit, take for n, we have to take set bit of n. To know the answer of set bit of n, we want to do take set bit of n by 2 plus set bit of n mod 2. It can be also written as right shift 1 plus set bit of n and 1. So this approach is math approach, and this approach is a bit manipulation approach. Fine. This is the code. It is the approach. Fine. Now let us see the code. Before that, we can see the time complexity and space complexity. Tell me what is the time complexity. Just see. Time complexity. We are traversing this array only one time, right? We are traversing this array only one time. So I can say the time complexity is O of n. And what is space complexity? It is O of n, because we are using an auxiliary space. But still, whether it is an auxiliary space or a resultant array, is a resultant array, right? It's a resultant array. So do this resultant array. It takes any space? No, right? So be careful. It is O of 1. Fine. Now let us see the code. Here's the code. See here. First I am taking empty array or empty list for I in range of n plus 1, so that if they have given 2, I have to go up to 2, 0 to 2. Then num is equal to I, c is equal to 0, while num rem is equal to n mod 2. If rem is equal to 1, I will do c plus is equal to 1. Then I will just right shifting. Right shifting means it's just dividing by 2, right? See here, it can be also written as what? Num is equal to num and 1, right? And this can be also written as what? Num is equal to num right shift 1. Fine, fine. These are the methods I have already taught in the what? Bit manipulation basic, right? I will give that link in this description. You have to watch that and then proceed with next problem, right? So because there are so many concepts in that video, right? Now at last I'm just appending the count, then returning the array. Fine. So this is my first approach. This is my first approach. Let me comment this. Now let me run this. This is my first approach. We can also use Brain's algorithm. You may use the Brain's algorithm here. If you don't get answer or you have some struggles in that coding part, just comment below. I will try to put videos separately for the Brain's algorithm. Fine. Now let us see the next approach, dynamic programming approach. As I told you, in dynamic programming approach, we initially said that 0 and 1 count 1 in this as a 0 and 1, right? Because see here, the 0 and this 1, the two are set to initially 0 and 1, right? By using this 2, we can compute all other elements. Just see, for this 2, what will be set bit? It is the set bit of 0 plus set bit of 1. Fine. For this 3, it will be set bit of 1 plus set bit of 1. For this 4, it will be set bit of 2 plus set bit of 0, right? So that we initially want these two values alone. So just take if I is equal to 0 or I is equal to 1, just append I, right? Else if that's not a condition, L dot append of L of I mod 2 plus I divided by 2, right? That's what I have told you. See here we have arrived a formula like this, right? So that's what I have written here, and then at last I am returning the result array. Let me submit it. Fine, it is submitted. So these are the three approaches because Brain's algorithm also approach for this problem. So you have to try that Brain's algorithm. Thank you.